Hi, everyone. My name is Beena Amanat, and I lead our global Deloitte AI Institute. And today we have Dr. Manuela Veloso. She is the head of JP Morgan Chase AI Research and a Herbert A. Simon University Professor Emerita at Carnegie Mellon University, where she was previously head of the Machine Learning Department and faculty in the Computer Science Department. Manuela is an accomplished researcher with interests that are in AI, symbiotic human robot autonomy, continuous learning systems, and AI in finance. Her accolades include the National Science Foundation Career Award, Alan Newell Medal for Excellence in Research, and the Einstein Chair Professor of the Chinese Academy of Sciences. Manuela, welcome to the show. I am so excited for our conversation because you have such a unique journey and a unique role where you're straddling between academia and industry. So let's start with, tell us a little bit about your story, your career so far, and how did you get to where you are today?
Okay, thank you for having me. So I basically started my AI journey with my PhD in computer science and AI in particular in the early 90s. And then I became a faculty in the computer science department at Carnegie Mellon University. And then I was the head of the machine learning department later on, also at CMU. And in 2018, I joined JP Morgan Chase as the head of a group in AI research. In terms of education, also, I am by education an electrical engineer. And then I did electrical and computer engineering for my master's and then computer science for my master's. So I kind of been in this, computing discipline for a while.
And what got you interested in finance specifically and that intersection of AI and finance?
Oh, that's a good question. I mean, I have to confess that I did not did not search specifically for this intersection of for this interest. It was more of an opportunity that came up, and basically, I was approached to start this group at JP Morgan Chase of AI research. And in my career, I decided that this was the time if I wanted to try something different to do it then. And
Mm.
so, and I've been since for the last 40 years plus in a very large and a very complex and a very fascinating kind of like industry and
Yeah.
the financial services. And I've been enjoying a lot what I've been doing. Before that, I spent 30 years or close to 30 years doing robotics. So,
So, what does the head of AI research at JP Morgan do? What does your day look like? What are some of your focus areas?
it's a good question, right? So, there are many applied AI groups that work on a lot of problems that are more like really needed for the business as we speak. Somehow, as AI research, we have the opportunity to think about transformation, to think about somehow innovate processes and try to open these lines that can lead into some more deeper transformation.
Mm.
But
Mm.
in some sense, also one of our roles here is a lot related to education too. So we're culture change of trying to understand. There is this famous question that I think everybody has is that it's about like what can AI do after all? You know, there is
Yeah.
this about wow, what is this thing about AI? And there is a lot of like AI and machine learning, and the two terms seem to be used interchangeably. And of course, I don't think that AI is machine learning only. And so a lot of what we do here also is try to look at the problems with these. I mean, I believe a very long and experience of teaching AI,
Mm.
researching AI that I bring to the picture. So it's a combination of my experience, these amazing problems that make it fascinating. And AI research is a group I built that We all have PhDs. Most of us, 60% of us, have PhDs in computer science, in AI, in machine learning, in math, in statistics, and electrical engineering. Then we have a lot of masters too, people with master degrees in the same area. So people obsessed in some sense with solving problems through computation, intelligent computation, and trying to bring such solutions to financial problems.
Yeah, so true. And I believe the original quants, right, before they were called data scientists, actually came from the financial services, is what I've seen. And, it's just that, what used to be done primarily with statistics, and we've always had quant groups, became this new discipline around data scientists. It's fascinating. And, financial services specifically can do so much more with AI because it's a data rich industry, right? There's always been data due to regulation and compliance. So, there is so much, that you can advance in the AI journey. How
But
is your team structured? Yeah.
Let me just explain one thing about this that I want to clarify here.
Yes.
Data is great, but there is more to life than data. And
Yeah.
I really want to us to have this opportunity to explain this a little bit. I mean, in a sense, let me just give an analogy with soccer. The rules of the game exist before the actual game. So there is knowledge or chess. The rules of chess exist as something that's principles, that are rules.
Yes.
And then the data provides, in some sense, illustrations of how a game is conducted, executed, be it like soccer, be it like chess. So what I believe is that we cannot just think that data has all the information, because in some sense, people and the regulators and every single process has their own rules. So their own principles. So when people think, oh my gosh, the rules are old AI or I don't know, now it's just data. It's not the case that we need to give up on all the knowledge that people have, especially in the financial industry. People have so much experience, they have so much knowledge, they have so much kind of like also principles that they are supposed to follow. So I bring this view also that AI is about how do we represent those principles? How do we find, how do we assist humans in providing information about the processes, which are not exactly just the real data use of like extracting from data, like patterns of how the customers behave. But it's like all these scenarios of representing us. And I just want to add one more thing. That so why is this so challenging, and why do we need AI for this? It's because it's hard to represent principles, especially when they are changing. Even the regulators' rules are changing. They give us again next time another big document of 400 pages, and you have to now find how these 400 pages are different than 400 pages of last year or last month. So there is this problem that the AI can enable the processing of all this information, correlating, finding differences. And that's not necessarily just data that you feed into some machine that classifies. So AI is a much bigger heart than just classification and the actual prediction based on data. It's very large AI.
Yeah, Manuel, I completely agree with you that domain knowledge, the subject matter expertise is crucial, right?
Crucial.
It is absolutely important. I will clarify more in terms of, what I was sharing was in some industries, like say, for example, manufacturing, right? Or where I've had experiences also in the industrial cases, right? Predicting jet engine failure. There was not enough data, right? We had the subject matter expertise, we had the compute power, but not enough data because those machines were not set up in a way to capture data, right? And then you cannot do effective IoT. So at least there is one leg of the stool, right? The data, compute, and subject matter expertise. When you try to think of it that way, there is at least one step of it is taken care of. But you're absolutely right. You cannot make progress without the subject matter expertise, the principles that you mentioned. And, it's, I think we've also moved beyond that phase of where you expect your data scientist or AI researcher to be an expert at the subject, right? To be expert, right? Those are unique roles and need to be filled by experts in each of these areas to produce the most effective AI solutions. How is your team structured, and do you have the subject matter experts as embedded within the research team, or how do you do that kind of cross pollination across the teams?
That's a wonderful question, and that's probably the biggest challenge because
Yeah,
the subject experts, one way or another, have their processes, and they don't. There is not a clear need for AI. I mean, in the sense that
yeah,
everything works perfectly. I mean, believe it or not, nothing, and nothing fails. Everything works perfectly. And AI is more of an opportunity for improvement or for more effectiveness or for assisting than really a need. So the
mm,
way we function, and this is important for us to understand, is like this: we interact a lot with the business. And especially, me also coming from a world that had no finance background, we are always in this learning mode from the
yeah,
financial.
yeah,
Except that the difference is that when we hear problems, we tend our background makes us think about the problems in a different way. So we kind of like hear about the problems, and then we first of all think, oh, this is the same thing as these other problems, or this is all about making sure we are able to do some kind of optimization here.
yeah,
So have these building blocks in our mind: optimization, search, representation, classification, learning. And basically, we are trying to match what the business tells
yeah.
us to one of these solutions, one way or another.
Mm-hmm.
And for example, I'll give you an example, which it's an interesting example from my point of view. When I joined JP Morgan at the beginning, I was brought to the traders floor. And we were
Yeah,
like, I was visiting the traders floor, which is fascinating what's happening, but I could not see more than basically people standing surrounded by screens full of plots of assets. I mean, so
yeah,
basically, it was like a bunch of like time series data plotted on screens around these people that were making decisions. So when I looked at this, I mean, and we were trying to bring AI to this decision making. Of course, we explored reinforcement learning solutions, but I look at that and I can only see images, and
yeah,
therefore, it's only I can only see pictures, and they are pictures of time series data for sure, but they
yeah,
are pictures and images. And
yeah,
so, based on a lot of the work that has been done in AI and deep learning using images for so many compelling problems that have been solved, from face recognition all the way to object recognition, I actually developed a solution or an approach in which we use actual images, so pixels, to actually also make decisions regarding trading. It's not a solution that has fully been deployed yet,
yeah.
but it's a very different way of looking at the problem, and we can show that it does really well too. So, and that's an example. But other examples that I would like also to emphasize is the following: in computer science,
Yeah.
we have many data, a lot of data, and we aim at standardizing the data. We kind of want to represent all the objects the same way. We put as many properties as needed. Currently, in a firm that's large, that covers many countries, many regulations, many sources of the data coming, the data is very it's not very uniform. So just
Yeah.
to say the least. I think that one of the contributions of AI also is to bring that standardization
Yeah.
potentially. as the representation of the concept, and then enable the translation from different types of representation to the standardized one. And if
Mm.
we solve this problem, if we solve the problem of, and we have been working on these representing companies, standardized representation of companies, whether the information comes from websites, from annual reports, from documents, from all sorts of communication, that you bring all of that information through basically natural language processing into the standardized representation, and then use this representation to do the matching with companies to investors, to do the matching of companies to all sorts of that. I mean, so all sorts of needs that you have to process a company, now it's in standardized form. So
Yeah.
these principles that, images, the value of images is one example. The value of standardized representations is also something that AI brings to the industry. And another, so I could give many examples. We have a lot
Yes,
of projects.
please.
I can give another example, which is
Yes.
the concept that we use now of actually searching. So think about problems that require looking at many alternatives, be it
Yeah.
reconciling like different ledgers and statements, and be it like all sorts of like other matches that you have to to go through all possible alternatives. The combinatoric nature of many of the problems that are done in the financial industry. Now AI is one of the
Yeah.
best to really do this search. So basically, we now look at problems from an optimization point of view, not only as mixed integer programming, which we can do, but the AI magic is the formalization of complex problems into a way that then the mathematical techniques can actually be applied to solve it. So there is this representation issue. How do you represent ledgers and statements and all sorts
Yeah.
of transactions and payments in a way that then you can do this mixed integer programming to solve it. So that's the beauty. And of course, there are many techniques. AI is always using many techniques in math, in statistics, in all sorts of engineering. But the secret is this representation thing. How do you formalize if you are mixing traffic, if you are missing all sorts of information into a single framework? And that's
Yeah.
basically the power of AI is this knowledge representation and the combination with algorithms, with ways of searching the information. So search is a very beautiful tool that we also brought to the industry. I mean, to many of the business problems, to analyze in a very elegant way combinatoric solutions, and to eventually determine what are the best solution under which conditions.
Yeah. So Manuela, all these amazing AI solutions, the tools that you build, it's all, I feel success is fully dependent on the adoption, on how many users actually take it, use it. And what are some of your best practices on driving adoption, thinking about the user upfront and making sure that you will get the level of adoption you need to make it into a successful project?
This is a very good question about the adoption, and as I try to understand it like this, we've developed many projects that are basically, especially in the AI research, proof of concept. I mean, they are sometimes quite away from the way people solve them, and therefore it becomes more difficult to engage on that change. However, the magic is the following. There needs to be someone in the business side who really believes and is not skeptical. And if they, in fact, embrace this change and they embrace the great potential that eventually these techniques have, then something happens. So it's kind of like I'm in kind of in the search of people who actually believe that there could be a change, that there could be a different way of doing things. If you don't find these people, it's very hard to really impose. You can't, because people are doing their own business. And so we are, no matter what, still outsiders. I mean, the business goes on. You have to balance accounts, you have to make loans, you have to invest. So there is a whole business. It's like entering a hospital and telling like the surgeon, yeah, do it like this. I mean, they have their own functions.
Yep.
So now the question becomes that when we find these people who actually, there are many here in where I work, where they are believers that this can make a difference, then it's beautiful. It's beautiful because they engage explaining the business rules. They engage explaining like what is the potential impact of the techniques.
Yeah.
And then basically there is a moment, which is the thing that I also want to emphasize, in which this magic of AI transitions to the business, and then don't know anymore. They just take over and they do it. So, for example, I tell you, we have done some work a couple of years ago on trying to automate the generation of some of the reports, because the data is all in some files, and then basically you need to convert that data into some language, and you need to convert that language into insights, into tables, into numbers. So we did this AI to generate these documents automatically. We call it DocuBot. And basically now some of the business uses it, and we just know they use it. And sometimes it's not really, they adjust it to what they actually need, and they do all these kind of like different aspects, different variables for different use cases. And it's beautiful when we see that eventually you contribute in that way. So we don't follow all the way to seeing the actual outcome coming out. But I think that through business is like the same thing with these reconciliations and applying search to math. I mean, it's beautiful that eventually the business takes over, understands the value, and then it makes it happen. Because the important thing about business versus AI or versus as research is the scale. I mean, this business is to address all countries, all rules, all thousands and millions of transactions. It's the scale. While we in AI, we know that the scale exists, but we think about like this. Okay, let's reduce the scale to these typical examples. Can we process them? Fine. And then the business has to handle the actual running this. And so, but one final thought about this business and AI. And I hear many discussions about this. Oh, you have to learn tons about finance. Oh, they have to know tons about AI. I think that this is not the way to collaborate.
Yeah.
I mean, I understand enough eventually, and I will hopefully improve over time to be able to have a conversation. But do I really need to know the basics of derivatives and the basics of customer service and the basics of like ATM machines and how do you? No. Do they need to know how the algorithms for a search or for representation or for heuristics and for a source of like deep learning and adjustment of parameters and no. So that is, it's like the beautiful thing is to keep that knowledge in the right place and to still be able to collaborate. So when people say, oh, we don't know anything about AI, you need to know enough to when you talk about search or when we talk about heuristics or when we talk about knowledge representation, you understand something. And we have actually developed an AI Academy that includes these little lectures on AI can search, AI can do reinforcement learning, AI can learn from examples, AI can process natural language, AI can do machine vision. And they are like a portfolio of 15-minute lectures, very short, on really like the capabilities of AI. And that's enough. And sometimes, even the other day, someone told me, I mean, your AI can search is difficult. Even if I made it like the simplest possible way, I still have to redo it slightly so that it's more understandable by people that don't know what necessarily a graph is or nodes or search. So, but that's I think the beautiful thing about AI research also here is because as I have this teaching background all my life, I thought, I've been teaching all my life. So for me, it's natural to try to explain things in a way that eventually the audience can understand.
Yeah. Yeah.
And that makes it slightly easier for me to be in this position of bringing this AI
Yeah.
education.
But we're definitely seeing, and I've seen it as well, is more and more companies having this basic AI literacy training, right? Just so
Yes.
that you can all speak to the same language. It's like the alphabets of AI. And
Yes.
I would say 10 years ago there was an expectation the data scientist was a unicorn, right, who knew all these skill sets. But we've certainly now realized you need that deep expertise, and you need to be able to collaborate, right, to drive the most outcome. And
Yes.
AI literacy is becoming more and more crucial as
Yeah.
AI itself advances. So that's what, one of the challenges is that culture change that you need to drive along with, bringing in AI into the organization. The other one that we hear a lot about in our field is around the topic of ethical AI. What are some of your thoughts on this, and how do you think about it? How are you addressing it?
So we actually have research pillars
Hmm.
we organize along 7 research pillars. One of them is exactly about the values of society, not only
Mm.
ethics but fairness, ESG, all sorts of values that are a bit orthogonal to the techniques and a bit orthogonal also to the financial actual service. It's
Yeah.
like these values of society. And the important thing for us here to understand is the following. Studies AI does not have intentions. I mean, there is so
Yeah.
code, right? The problems always are with people, not with really AI. I mean, AI only enables eventually people to manipulate you or to do unethical things, but it's not because AI itself have anything inside. However, we have we have a center of excellence in my team at JP
Mhm.
Morgan on explainable AI. So one of the
Mhm.
first things that we delved into is the problem of actually understanding why. Why is the machine saying no loan, loan? Why is the machine saying this price versus that price? And you have all this infrastructure. You learn some decision tree and you used 400 features, and then magically the thing says, what? $112. Is that's like what the price should be? Or no, you don't get loan to this particular person. And then there is this kind of like, why in the world does this thing come up with? So explainable AI is
Yeah.
something that we have been working a lot to try to break this gap between the machine, the AI, the code, the algorithm running, and the actual user understanding. Notice the difference between these type of like explanations or versus the matching. The matching problem, if you say that 10 is the same as 5 plus 5, nobody has a problem with that. You don't really need to explain that you might have to explain on what the match is. Why didn't you match 10 to 8 plus 2? And then, but not really like the essence of explanation. So we are working on these explanations, looking at eventually trying to bring out the features that were relevant for the decision, trying to organize features along time and along different type of like classes, and all sorts of like trying to bring explanations. At the same time, in coordination with people, regulators, with people in compliance, we
Yeah.
try to it's very beautiful. We try to use AI to search different subsets to prove that this is right by contrast with others. So we basically go and say, what if we had used all this counterfactual thing? What if we had used all these other features? And then everybody's happy to see that the result, if we had used these other features, would have been worse in the metrics we are trying to use than these ones that the AI came up with. So we do a lot of like, I'll just say again, like analysis of like what if scenarios, counterfactuals, and counterfactuals can also be used as explanations. The ethical problem is complicated, and recently we have several people that joined the team for responsible AI. So
Yeah.
And we are trying to find principles also. There is a lot of work being done in the community, in the AI
Yes.
community on ethical AI and values of AI and principles of trying to bring all these type of like training with the right data, having the right tests, being able to put the right principles, even having diverse teams working on the development. If you have teams that embrace the diversity of our society, and we may bring more ethical decisions on the code itself. And
Yeah.
I just want to tell that the contrast between these days and AI in industry and early on when I was in the university or when I
Yeah.
did robots that go up to Mars or robots that play
Yeah.
soccer, the big difference is the following. Here, the concern with these problems, which is very well concerned, brings multidisciplinary teams together. You bring the people who know about the social impact of things with the people that actually know how the making should be represented and how the code should be written. Which
Yeah.
in the past, when we are playing robot soccer, you don't have, it doesn't matter. What does it matter
Yeah.
scoring one goal more or one goal less? It
Yeah.
doesn't have the human as a target. And here, the fact that the social scientists play a role in these conversations, the lawyers play a role, the people that understand philosophy play a role, the ethical people play a role. So it's for me, it has been also transformation coming from academia to
Yes.
industry to open my mind
Yeah.
also and my techniques to these ethical values and these societal values. So I honestly say that I was not thinking that much about these issues
Yeah.
when I had robots move around Carnegie Mellon delivering tasks,
Yeah.
bring me coffee or
Yeah.
take this package to the. I just wanted to make sure that the robots would not hit anyone nor bump into any
Right.
chairs, and they would come back and they would know where to go. So it was the
Yeah.
emphasis was more on functionality than
Yeah.
on values. Now, we
Yeah.
cannot afford to do that only functionality thinking in a
Yeah.
lot of your problems that we encounter in financial services, given that there are humans. I mean, okay,
Yeah.
I cared about the robots of going over the humans,
Yeah.
but I didn't care about the robot, smiling at people or the robot being nice. I mean, no, it was just
Yeah, 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 yeah.
not for
I
thought.
totally understand. I'm a computer scientist by training as well. And it's, our focus is all on, the things that it
Function.
can do, right? The functionality and not necessarily the negative impact. So I totally can relate to, the way where what you're describing. So, Manuela, recently you were elected to the National Academy of Engineering for your contributions to AI and its applications in robotics and the financial service industry. Can you tell our audience a little bit about your research in AI and robotics and
Yeah.
what have you learned?
Very nice. So I do. I'm very humbled by this honor, and I really believe that it has been a lifetime of experience. But let me explain to you. So I always in robotics
Yeah.
worked on this problem of connecting perception, cognition, and action. And I look at AI as basically this using the data to be input to the decision making and then eventually to execute the decision. So robotics gives us this heart on all areas of this intelligence, not just doing natural language, not just doing machine vision, not just doing planning, but robotics is about, well, this robot needs to move. This robot needs to do a task from beginning to end. So there is this perception, cognition, and action, and its integration. That's what I always lived as my AI experience. And so here is the same thing. At JP Morgan, because of this experience and this AI in the financial industry, I look at end-to-end products. I mean, I like to see what is this data. So why do we do so I don't see myself as a data scientist. I see myself always an AI person because I don't just analyze the data. I want the data to be then given what do we do with it? What is the action you need to take? And eventually actually do the action. So I bring this kind of like a connection between data, reasoning, and action and more, and get feedback and be improving over time, and being like a learner from experience, not just
Yeah.
learning from data, but learning from doing, learning from instruction, learning from observation. So all these other techniques that we use in robotics that I mean that are very helpful to have this more how do you say complete view of learning, not just the data. Then you have to actually talk with the person. You are a chatbot. You have to talk. You better become better over time. You better
Yeah.
learn. That's the challenge: is to think about AI not as a one-shot kind of like system, but as a road, a journey. AI is a journey. It becomes over time better and better. The humans say things, and eventually this is like an experience process. So
Yeah.
I bring that from my robotics experience, because they kept like not scoring goals at the beginning, and then over time, with more inputs from humans, they ended up knowing more what to do, and the robots moving around too. So my robotics world has always been about mobile robots. I mean, not only manipulate. There are areas in robotics manipulation, all sorts of planetary experience, autonomous driving. My robotics was always mobile inside of the
Yeah.
buildings. A lot.
Yeah.
I was more restricted. But another thing that it brought, that AI and my experience in robotics brought, which I think is extremely relevant, and I'll share this final thought with you about this, is the following. Back in mid 2010, 2015, when we were moving our robots at Carnegie Mellon, these famous cobot robots,
Yeah.
what happened was that we realized that they couldn't do everything. There was this issue about they could not open all the doors of the building, no matter what actuators we would have. They could not press the elevator buttons of the elevators, and they could not pick up things in the kitchen. I mean, they could not pick up packets. Even if we would give them arms, it would have been hard to pick up any package. So there was that moment in which I realized that, unfortunately, these robots would always have limitations.
Yeah.
Limitations, the problem of accepting that AI and the robots exactly that I was developing had limitations. And so we introduced this concept of symbiotic autonomy, in which these robots ask for help from the humans a lot. So the beautiful thing is that the humans didn't have to follow them. They will just stand there in front of the elevator and say, can you please press the elevator button for me? Or can you put something in my basket? Or can you take these out of the basket? Things that they cannot do. And so it changed my way of thinking about AI, in which I was thinking, oh, AI can do it all. They will play soccer as well as humans, and they will do all this stuff. But then, no, I realized in the mid-2000s that it was not the case, that they were going to be able to do everything. And that has changed the way I perceive problems, even here, because I say, oh, this is so hard. I mean, this is really a very difficult decision. That's fine. The machine needs to say, I cannot do this one, but I can do that one.
Yeah.
So it became an architecture of thinking in which you now test if the thing is like AI solvable, and if it's not, happily the human will solve it. So it's I believe that the future, even this ethics, all these questions, the future is about understanding how AI and humans can work together. We'll never only be humans, and we'll never only be AI. I mean, it will always be here. We know much more than this AI does in many things. But this AI can do repetitive tasks much better than we can, much more accurately than we can. It can do searches. It can search information like no human can. I mean, I cannot go through all the web pages of the whole world, and AI can. So this is the magic of this discovery of AI, is to try to make these humans and this AI build better on their own capabilities. And it's not about denying that the AI exists now. And it's not denying that humans have knowledge. They do. So that's the magic. And I learned this in my robotics because in some sense, there was that 3 a.m. kind of acknowledgement that, oh my gosh, they will not be able to do it all. And I realized at that moment that this is it. And you need to embrace that they should be asking for help. They're surrounded by humans. We don't have any problem pressing an elevator button. We
Yeah.
don't. We don't
Yeah.
have any problem putting something in a basket. We don't. But we may not want to go all around the building, delivering all these packages to the whole building. Okay. Okay. So then what? We
Yeah.
combine the two things. So that's
Yeah.
what I believe is the secret here is this
Yes.
amazing combination of AI and humans.
Yeah.
And so that's what it is. I learned this from my robotics and I'm bringing it to the financial services too.
That's so true. So the magic is humans with machines is the
Yes.
most powerful use. I love it. So Manuela, what are some of the advances you're seeing in AI, whether it's with generative AI or image recognition? What are some of the advances in AI that you are
Okay.
most excited about?
I have to confess that the advances of AI to process language are amazing. Amazing. And having worked so much with robots, I did not have my heart on the language for many
Yeah.
years because I cared about images, I cared about lidars, I cared about sensors. But language, we have it in Cobot, but just minimal interaction with humans. Get
Yeah.
me coffee, go to Manuela's office, not Shakespeare and not any kind of document. It was just very plain language. So
Yeah.
coming to JP Morgan, coming to the financial industry world, you have to realize that the humans communicate with other humans through language. This language thing is ridiculously pervasive everywhere. Documents, phone calls, conversations, everything is about humans talking or writing. And therefore, all the advances that AI has done on these large language models, on these extremely convincing language processing are amazing. So I have a big admiration for all the results that have been shared with everyone in language.
Yeah.
Unbelievable. I do
So true.
think that images will also play an equal role. I mean, even going back to my first example, because we make so many decisions based on what we see. So I think that images are a little bit underrated now because it's all only images for object detection. But we humans, we look at the sky, oh, whoa, it's dark. We take an umbrella. So we make so many decisions. We look at how the face of that person, oh, they are sad. You talk in a different way. Everything is, so many things are driven by what people see, not just what people hear. But just to tell you to answer your question, language is what I think is the best. And of course, all the learning, all these amazing algorithms to be able to process enormous amounts of data. But when we combine the missing data with the human knowledge, that's also a big secret for the future. I think we have to do more on that. But language, I tell you, maybe other people say, oh, she's so naive. She thought, but that's what I believe it's a major accomplishment. Now, I do want to add one more major accomplishment just to cover everything that we have been working on also, which are the ability to really create synthetic data. So the fake data problem, which can be considered, if we call it fake, it seems that it's bad. If we call it synthetic, it probably has the right good use. When you don't have enough real data, even fraud examples or, all other examples, when the data is very limited, by creating this synthetic data, you can really do really much better in terms of using AI to use the data, the real and the synthetic data. We have results that show a great improvements on AI systems by using also synthetic data, which we can generate either by expanding the real data or by using models. We can use simulations that create the same type of data through principles. And so I think synthetic data is very important. And finally, one thing that is the most kind of like not used yet but I find it fascinating, which my experience with Robot Soccer is the simulations of multiple agents, interactions
Mm,
between multiple agents.
mm.
Because these multi-agent, the game theoretical aspects, the security aspects, the crypto aspects, if one talks with the other but doesn't want to give the right information, that they need to coordinate, they need to do joint computations. These amazing world of multiple agents, not just one. It's like all of them. We have a very big area on multi-agent simulation and multi-agent privacy that these
Yeah.
distributed kind of like systems. We cannot
Yeah.
imagine that we have a single AI system. I mean, it's going to be this AI system, it's going to talk with some other AI system somewhere else. And, and these humans need to talk with other humans. So this is all the world is all about multiple parties, multiple
Yeah.
negotiations, multiple understanding of like interests, all sorts of dialoguing. And unfortunately, I believe that these algorithms for language, and deep learning did not yet embrace the commercial aspect on these multi-agent, on these
Yeah.
ability to reason about multiple aspects and multiple agents. So multi-agent, synthetic data, standardized data, all sorts of language, vision, and all
Yeah.
sorts of like a search and optimization and representation. Wow, we are covering the whole world of AI.
So true. Manuela, you're doing some cool work. How can
It
people
is.
stay connected with you and follow your work?
Okay, it's a good question. I'm not very good at all the social media, but I do have one web page which I keep updated with our publications, which is the most exciting things happen there. It's at Carnegie Mellon. If you Google it, you are going to see that web page, which has some of research projects and then a pointer to our jpmorgan.com/AI website, which is an external website in which we represent all our
Yeah.
problems, our projects, the collaborations with universities. We have a very big mission of staying connected with universities, with the community. Everything is there. jpmorgan.com/AI. And my email address is also there.
Manuela, that was great. Thank you so much for being with us on the show.
Thank you very much also for having me.
Thanks to our audience. Be sure to stay connected with the Deloitte AI Institute for more AI research and insights. Take care.